Okay, we're going to take a look at levels 4, 5, and 6 from the Solving Equations level up. So starting with level 4 here, we're trying to solve for x. We have the equation 3 minus w equals kx over 2 plus 3yx. So right off the bat, we should notice that there's two terms with x in them, and that it should be our goal to combine these terms. However, we have coefficients of kx over 2 and 3yx, so we're probably going to look to factor out x. One solid strategy that I saw many students using was if we want to deal with that 2 in the denominator, one sort of elegant solution is to just multiply both sides of our equation by 2 right away, and that'll handle the 2 in the denominator and make it so we don't have to work with fractions. Remember that 2 distributes to all of the terms on both sides of the equation. So 2 times 3 is 6, minus 2 times w, 2w. 2 times kx over 2, and the 2's cancel, and we're left with kx. And then 3yx times 2 is 6yx. Okay? So that's a very wise first step, because it gets rid of the fractions and allows us to focus on isolating our variable that we're trying to solve for x. And so now that we're structured like this, we can look to factor out x. So that's what our technique is going to be to deal with x without being able to combine like terms so easily. So we're going to factor out x from both of these terms. We'll get 6 minus 2w is equal to x, k plus 6y. Now to solve for x, all we have to do is divide by k plus 6y on both sides. And we're left with x equals 6 minus 2w over k plus 6y. Okay. So a rather elegant way to deal with the fraction and allows us to solve. And there's other paths we could have gone. We could have factored out x right away and then dealt with the fraction later on. But it's sometimes nice to really deal with them up front, especially if it's as simple as multiplying both sides by 2. Moving on to level 5. So now we're looking to solve for a. And right away, I can see that there are 2 terms with a in them. It's in the numerator and the denominator of our right-hand side of the equation. So we know we're probably going to need to multiply both sides by a. But if I look on the left-hand side of my equation, I see that we have 2 fractions that are being added together. And personally, I'd kind of like to get those combined right away. So all I'm going to do is multiply this side by x over x and this by 4 over 4. Because we can multiply by 1 and it remains the same, we get xu over 4x plus 8 over 4x equals negative 2a minus 3 over ka. And now that our fractions on the left side have the same denominator, we can combine them. So xu plus 8 over 4x equals negative 2a minus 3 over ka. Okay, our goal is to get a's combined, and we want them kind of all in the numerator. So what we're going to do is multiply both sides of our equation here by, and let's do ka. Okay, and so this cancels on the right-hand side, leaving us with negative 2a minus 3. And on the left side, this is like multiplying by k over 1. Ka distributes to each term in the numerator. So I can distribute here and here, if I so choose. And I will for this purpose. So I'll say kaxu plus 8ka all over 4x. Okay. Now I'd like to get rid of the denominator so that I can just start looking at combining terms and not worrying about fractions. So I'm going to go ahead and multiply both sides of the equation by 4x. It's really important that when we do this, we are multiplying 4x by the entire side. So here 4x distributes to both of these terms. So we end up with negative 8ax minus 12x equals, and then kaxu plus 8ka. And on the left-hand side of the equation, if we're multiplying and dividing by 4x here and here, they cancel, and that's why we are able to get rid of all our denominators. Okay, so now we notice that we have an a in this term, in this term, and in this term. So we kind of want to combine like terms. We want to combine into a single a to be able to solve for it. So we want all the a's on the same side of the equation. So right now we're going to add 8ax and add 8ax to both sides. Negative 8ax plus 8ax cancels on the right, that is 0. And on the left, we will end up with 8ax plus kaxu plus 8ka is equal to negative 12x. Beautiful. Now we are ready to factor. So we have a in this term, and this term. They have a common factor of a, so we're going to factor out the a. And we get 8x plus kxu plus 8k. Because if we were to distribute that a back in, we would get back to our red equation above. So we factor out a, it's equal to negative 12x. If a times something, this thing, is equal to something else, well then if we divide by that thing, so we're going to divide by 8x plus kxu plus 8k, cancels away and leaves us with just a is equal to, and on this side of the equation we also divide by 8x plus kxu plus 8k. So we get a is equal to negative 12x all over 8x plus kxu plus 8k. So solving this problem required two things. We had to deal with the fractions. Okay, and I chose to do that by first combining like terms. So I wanted to combine, or get a common denominator to combine our fractions, excuse me. So I wanted to get this common denominator 4x and combine, and then I sort of multiplied both sides by ka, and both sides by 4x to eventually get here with no fractions or denominators. And then the other thing we need to do is we need to get all our a terms. We wanted all our a terms together to prepare us to factor. So those are the two key things here. And you could have dealt with the fractions in a different way. You could have multiplied both sides of the equation by kax times 4, and you could have cleared all your denominators at once. But there's multiple ways usually of dealing with things. You know what, let's show what that would look like. So if we wanted to just clear the denominators all at once, I'm going to erase this here. Okay, so say I wanted to clear all the denominators right away to deal with the fractions. I could multiply everything by 4xka. So I can multiply everything by each of the parts or each of the terms in any of the denominators. So I can multiply all of this by 4xka. Okay. Now if we look to distribute that, here we get 4xka times u. So 4xka plus 2 times 4 is 8 xka. And then our denominator we can combine, or sorry, this is over 4. I'm getting ahead of myself. On the right side of the equation, we make sure to distribute this to each part of our terms in the numerator. So we end up with negative 8xk, a times a is a squared, minus 12xka all over ka. This might look a little messy, but we can cancel some terms. So we have a 4 and a 4 in the numerator and the denominator, so that cancels in our first term, and we get xkau. In our second term, we have x and x, so that leaves us with x, or 8ka. And then on our left side, we can cancel k from all our terms. And you can only cancel if it's in all of the terms in the numerator. But that works in this case, and then we can cancel an a in one of our a's up here. So we're left with negative 8xa minus 12x. And then at this point, we follow the same process as before. We want this to go to the other side, and then we'll factor out an a and we'll be able to solve. So that's another way you can deal with your denominators. It's sort of up to you how you see is more fit or more preferable for a given situation. Okay, and then moving on to level 6, it says solve for x and then y in the system of equations. So this, I notice, is really nicely set up to eliminate, because if we subtract these equations, 4y minus 4y is 0, the y's eliminate, and 10 minus 7 is 3. So if we do 2x minus ax, and if I bring this down for a moment, and my goal is to solve for x, well, I notice that I can factor. So here I'm going to factor out my common factor of x. And we're going to say x, 2 minus a, is equal to 3. And then to solve for x, I'm simply going to divide both sides by 2 minus a, and we get x equals 3 over 2 minus a. Beautiful. Okay, so now I've solved for x. It's still in terms of a, but that's quite fine. And now we're going to substitute this. So I can actually take this and substitute it in for x. So I'm going to say 2, 3 over 2 minus a plus 4y equals 10. Multiply the 2 in, so we get 6 over 2 minus a plus 4y equals 10. Here I'm going to start to isolate the y term, so I'll subtract 6 over 2 minus a from both sides. And that's going to cancel on the left, and we get 4y equals 10 minus 6 over 2 minus a. Now we divide out the 4. Okay. So y is equal to 10 minus 6 over 2 minus a all over 4. And that's technically true, but we don't really typically want to have fractions within fractions. So what we can also do is say this is the same thing as multiplying our numerator, 10 minus 6 over 2 minus a, times 1/4. Okay. Multiplying a 4th by 10 and then a 4th by 6 over 2 minus a, we get y equals 10 over 4 minus 6 over 8 minus 4a. Y is equal to 10 over 4 simplifies to 5 over 2. 6, 8, and 4 have a common factor of 2, so we can turn into 3, 4, and 2. And then this is about as far as we need to go as far as simplification goes. So this is a reasonable enough expression. If you wanted to, you could get a common denominator and turn this into a single expression, but this is just fine. Alrighty, so those are the level ups. Hopefully that's useful, and if you have questions, feel free to come find me and ask.